We are on Unit 5, where we'll be looking at bond valuation. So bond valuation, we'll get to look at the important terms that you need to inevitably know. We'll look at the types of bond valuation, and also we'll look at how to handle the semi-annual compounding. Then lastly, look at how to compute what is called yield to maturity. By definition, a bond is simply a long-term debt instrument, which is issued by a government or a corporation. In essence, the one who issues a bond is the one who's borrowing. It's an ironical term. So if government is issuing bond, indirectly, they are trying to borrow money from the general public. So the following are the terms that you need to take consideration of. There's what we call maturity value. It's also called the face value. It is a par value or the nominal value. This is simply the stated value of the bond. It is the original price at which the bond was what? Issued. So bond is usually issued at a par value, which is called the face value, which is the original amount borrowed by the bond issuer. So in the case of the US, the bond is usually issued at 1,000 US dollars, kwacha 1,000 kwacha, unless otherwise stated, which is could be 100 kwacha or so. Now, there are terms that you need to understand. We have what we call the coupon rate. Now, this is the stated interest that the bond issuer promises to pay. So the one who issues a bond is called a bond issuer. So there are three interest rates that you need to take note of. There's what we call the coupon interest, which is denoted by the small letter I. So this is what we call the coupon interest. So if, for instance, the bond was issued at par value 1,000 kwacha at 10%, I is 10%. Now the value of this I is capital I. It is called the coupon payment. 10% of 1,000 becomes 100 kwacha. So our I is a coupon payment. It's simply given by small I times the maturity value. So 10% of the 1,000 gives us our coupon payment, which is capital I. So we also have what we call the discount rate, which is given by KD. This is actually the market rate. The market rate is simply the rate at which our future cash flows are discounted to the present value. So this is a market rate. If not given and asked to calculate it, now changes its term to the yield to maturity as YTM. Then we also have a maturity period, which is simply the time in which the bond has full gestation. It fully matures. If you have a 10-year bond which was issued after 2 years, the period we're going to consider is 8 years because that is the operational period. Then simply the maturity date is simply the date at which the par value is supposed to be repaid. Now there are bonds which have a call provision such that the issuer of the bond may call back the bond before it matures. Of course, this one calls for what is called a premium or a call premium. So if you call back a bond before the date at which it matures, it is called a premium bond. So there are different types of bond we need to know. There's what we call a perpetual bond, which is simply a bond that never matures. It is simply given by the coupon value over the market rate, which is a KD. Coupon value divided by the market rate. An example is we have bond P, bond perpetual. It has a coupon interest of 8% and the market or discount rate. So the job of the coupon rate is just to calculate capital I. So small I is 8%. So maturity value or the face value is 1,000. So meaning capital I is 8% of 1,000, which is 80. So that is where the job of the coupon interest rate ends, to find our I. Then our discount rate, we divide this one by 0.10 or 10%. So it becomes a perpetual bond, which is $800. Most rarely, such questions are asked, but just for you to know. Then now the key bonds that we're going to look at are what we call the coupon bond. There's what we call a non-zero coupon bond and a zero coupon bond. So this is where I need us to really understand. I said there are two interest rates that you need to take note of. There is a coupon interest and the market rate. Now, these are very important in identifying the type of bond also that you are dealing with. So if your coupon interest is equal to the market interest, they are at par. So we call this a par bond. If your coupon interest is more than the market rate, this is good, meaning you're selling your bond at an interest. We call this a what? What do we call this when your coupon interest is more than? I'm sure this was mentioned in the previous class. And when your coupon interest is less than the market rate. So, do you remember these terms? So when they're equal to, it's a par bond. If it's more, it's a premium bond. If it's less, it is a discount bond. All right. So now we're going to look at how to compute a coupon bond. I'm usually very interested in using the manual calculations to computing the value of a bond, but I also teach you how to use our tables. So suppose we're given a bond, the face value or maturity value is 1,000. The coupon interest is 8%. The market rate is 10%. And the time is 5 years. So you're being asked to calculate 4 things. Number 1, the value of the bond, the annual bond. Number 2, the current yield of this annual bond. Number 3, the value of the semi-annual bond. And number 4, the current yield of this semi-annual bond. So to start with, what type of a bond is this? From what I've discussed with you, is this a par, discount, or premium bond? What type of a bond is this?
It's a premium.
It's a premium. Anyone else? It's a discount bond because our coupon interest, which we're interested in, is less than the market rate. It's a discount bond. So only becomes
I get it. Thanks.
premium if it was 18 here. All right. So the value of the bond is given by our coupon value. You multiply by the present value annuity factor plus the maturity value. You multiply it by the present value interest factor. So how do we find capital I? Capital I is simply found by what? Small I times the maturity value. So our small I is 8%. 8% of 1,000 is what? 8. So the job of the coupon interest is simply to find what? The capital A, 8. Are we together?
Yes.
Okay. Then the next thing we need to find is the interest factor. So this guy, the job is simply to calculate the present value factors. So we have two factors. There's the present value factor and the present value annuity factor. The present value factor is simply 1 plus R power n. So this will be, since it's 10%, 1.10 to the power 5. So what do we get? We get 0.621. So this one is an annuity factor, is an interest factor. All interest factors start with a 0. So it will come here. Then we compute our present value factor, annuity, which is simply 1 minus the present value interest factor divided by R. So the answer we found here, 0.621, we divide by the 10%, which is 0.10. So in this case, we're going to get 3.79. So this one is what comes here, 3.79. Then multiply your answers to find the final value, which is 924.2. So already our original price was 1,000 and we are selling it for 900. That still gives you a picture that this is a what? This is a discount bond. Even the value itself can tell you when you're selling it at a loss, like we are, it becomes a discount bond. So we also have, at this point, any questions before I proceed? At this point, any questions before I proceed? If I'm too fast, please let me know. You could as well have chosen to use the table. This present value interest factor, it's direct to the table, 10,5. 10%, 5 years. So let's check in the table. 10% under 5. So we go to 10% here. Then under 5. So this is a present value. It's a future value. So you need to be careful the table you're using. All present value, they start with 0 point something. So we're not going to use this. This is a present value annuity. Then we go to present value interest. So 10% is there. Then under 5. So this is 621 or 6209. It's the same thing. So is it telling with what we found? Yes. Then the annuity factor, the same present value annuity factor, 10%, 5. 10%, 5. So let's go to the table. Let's see what it's telling. So present value annuity, 10%, 5. So this is 3.79. Is that what we found? Yes. 3.79. So this is how we get the figures there. Then we go to our current yield. Our current yield is simply the coupon value over the value of the bond times 100. All right. So what is our coupon value? 8. What is our coupon? Our value of the bond? 924.2 times 100. What do we get? So 80. We're going to get 8.66%. 8.66%. That is how we find our current yield. Now, somebody would want to ask, what is this current yield? What does it measure? Current yield is important because it represents an investor's annual income. Current yield is an investment's annual income. It measures or it examines the current price of the bond rather than looking at its face value. It looks at the current price of the bond. It's very important to investors because it gives you a ratio of interest, which is payable on the bond to the actual market price. So this is why the current yield is important. So now we go to what we call our semi-annual bond. So from our time value of money, you will agree with me that interests are always divided by the number of compoundings. Semi means what? 2. So all interests, we divide them by the number of compoundings, and all the times we multiply them by the number of compoundings. All right, so we're going to redo this, except that now we're going to use the semi-annual bond. So since the semi-annual bond, our interest for the coupon, instead of it being 8%, what are we going to consider? Instead of it being 8%, what are we going to consider? So our coupon interest will therefore be a 4%. Okay, meaning our capital I will be 4% times what? 1,000, which is 40. That's why some books here will actually tell you to just divide the answer you got by 2. So we're at 80, we divide by 2 there. So this means that here we're going to have 40. And here we're going to, please don't divide the face value by 2. That one always remains standard. Then our KD is the market rate, which was 10%. Now it will be what? 5%. So our years, instead of 5 years, we're going to multiply by 2. Time is always multiplied by the number of compounding, which is 10. So we're going to now calculate our present value factor. So 1 over 1 plus R, the power time. Our rate is now 5%. So 1.05 to the power 10. So this is going to give us 0.05 to the power 10. 1 divided by answer, we're going to get 0.6139. 6139. All right. So let's also see whether it's tallying with our interest factor. That is under 5%, under 10. Let's check to tally. 5% under 10. Are we getting 6139? Exactly. You can use either way. It's direct, 6139. Then the interest factor, the annuity factor, present value annuity, 1 minus present value interest factor over the interest rate, 1 minus 0.6139 divided by the 5%, 0.05. 1 minus answer divided by 0.05 is giving me 7.7217. 7217. So let's go here. Present value annuity, 5% and at 10. So 7.7217. Is it the same? It is. So the reason why I encourage you to understand this is sometimes we're given percentages that have decimals and you get stuck. I know these tables are very easy, but they're not my liking because you're limited to discrete values. All right. So This way, I've simplified the formula for you to understand. I know some of the lecturers will use a longer cut, but usually in my teaching, you know how I love to simplify stuff, so they don't think so much. So this will give you 922.768. So this becomes the value of the semi-annual bond. So in this case, the current yield is value of the coupon times the value of the bond times 100. So this is 40 over 922.768 times 100. So in this case, when we divide that, we're going to get 4.33%. That is our current yield. Are we following? Is it making sense? Are we clear? Are we following through?
Yes.
Stella, are we following? All right. Sometimes you'll be given a 10-year bond. And now this 10-year bond has a 10% coupon interest. And is issued after 2 years. And to sell for 1,200. Now you're not given the market rate and you're asked to find the yield to maturity. The yield to maturity is actually the market rate. What's the formula for the yield to maturity? The coupon payment plus maturity value minus the value of the bond over N, then divided by this formula here. So if you're not given the maturity value, usually the maturity value is 1,000. All right, if it was 120 here, you know that the maturity value of the face value is 100. It's within the same range, similar. So here, some books will put payment, coupon payment, or they put I, it's the same thing. Others will put C, coupon payment. So how do you find the I? How do you find the I? If someone said, how do you find I?
We make I the subject of formula.
I, small I times the maturity value. Our coupon interest is 10% times the maturity value, which is what? 1,000, isn't it?
Yes.
So I becomes 100. Where there's I, put 100. All right. The maturity value is what? 1,000. The selling price of the bond is 1,2. And what is our period here?
2 years.
It was 8 years. Why 8 years? Why 8 years?
Oh, it's because the bond, the life of the bond is 10 years, but it was issued after 2 years. So it's like it has been in operation of some sort.
Exactly. So it's a 10-year bond which is issued after 2 years. When you compute this, we're going to get our yield to maturity at 6.6%. So this is our market rate. All right, so basically, this is how I can summarize this whole topic. We are done. This is the shortest topic, the easiest topic. Let's just go through our notes quickly. So bond C has been given with a face value of 1,000, coupon interest 8% for 30 years. So we know that 8% of 1,000 is where the 8 is coming from. 1,000 is there. How did you find this 10,30? We go into our table. The 30 is a period of time. And the 10, when you check interest factor, always starts with 0 point something. Present value factor is this one. So I don't need to go to the table. You know what's happening here, isn't it? So this is a discount bond. All right. Then you're given here, suppose we have bond Z 1,000, 10% is our coupon interest. 10 years is a maturity rate, the market rate is 15%. We're being asked to find the value of the bond 5 years after it was issued. So it is a 10-year bond, but issued after 5 years. So the time is 5 because of the difference in years. So small I times capital maturity value, the 100 is where the maturity value is coming from. 15 is the market rate. 15,5 will give us 3.3. 15,5, 0.49. When you compute it, we get 832. This is our bond. All right, the zero coupon bond, we use the same because there's zero coupon, the same formula we can use it, except that at the interest factor, there will be nothing to do with interest. Any questions so far? Are you together?
Yes.
Okay. So this is a zero coupon interest. So according to the formula for a zero coupon interest just has this component here. You know our formula is supposed to be our I, present value factor, then our maturity value, the present value annuity. So because there's zero interest, so this makes this whole part 0. So we're going to simply remain with this part here. So we have a zero coupon bond with a discount rate of 10%. So 10% under 30 multiplied by 1,000, you simply get $57. Semi-annual, I already explained, we simply divide our interest by 2 and multiply the time by 2. So if we're given bond C, which is 1,000, and it's a semi-annual for 15 years, and the market rate is 10%. So this 15 becomes 30 years. This 10 becomes 5, and this becomes 4. So 4% of 1,000 is a 40. 5%, 30 is because of what we have just explained. So when you check in the table, you're getting these figures, and you compute our value of the bond will be 845. So this is how we calculate the value of the bond. So the current yield, therefore, will simply be 40 over 845 times 100. Okay, so how do we determine the yield to maturity? The yield to maturity is simply the rate of return earned on a bond if it is held to maturity. This one is important for investors who want to buy bonds from the market. They want to know how much they will earn on a bond if they had bought it and held it to maturity. So this rate of return is compared to the rates on other bonds in the market to determine whether it's worth while to buy that bond or not. So we will have this formula that I gave you already. And you have the payment or capital I, value of the bond, N 2 VB over 3. So we have a bond issued at 1,000 2 years after being issued. This bond was sold for 1,200. The coupon interest is 10%, and it's a 10-year bond. How do you find the yield to maturity? So 10% of 1,000 is 100. Then the maturity value, 1,000 minus 1,200. The 8 is coming because the 10-year bond issued after 2 years. And then 2 times the value of the bond plus 1,000 over 3. So we already calculated this is 6.6%. So you discover that this happens to be the shortest and the easiest topic in your syllabus. Unless there's anything that you've not understood, I'll allow you to read the YouTube call on your own. It's a similar formula, but you read it on your own, and I'll send you accompanying questions to this note. I'll end my class here.